In this AutoStem trial number 2, we are using the same concrete block dimensions as in trial number 1, with 1.5 meters by 1.5 meters by 2.3 meters. In the second trial, we are also looking to look after the very valuable cables inserted in the concrete, but remove as much concrete as possible, and therefore going closer to the cables than ever before. In this design, we use the shop firer's experience and knowledge of the AutoStem product to safely break the concrete away from the cables. As you can see in this design, we have 4 rows of drilled blast holes at 10mm diameter. The 2 outside rows of holes are drilled to 800mm deep. The 2 inside rows of holes are drilled to 1 meter deep. The hole spacing is also 100mm less than the trial in block 1. This closer hole spacing is there to obtain a clean shear between the blast holes in each row. As you can see in this image, the 4 rows of blast holes are all drilled on an angle. These angled holes are there to align with the triangle shape created by the power cables inside the concrete, and they also act to remove the concrete in an upward and outward manner, reducing the pressure on the cables when blasting. If we look at the design of the 2 inside rows of blast holes, we can see that air decks are used in the blue, 1 9-gram cartridge is used in the red, and green is used for final stemming. If we look at the 2 outside rows of blast holes, which are slightly shorter than the centre rows, we can see that 1 air deck is used in the blue, 1 6-gram AutoStem cartridge in the red, and final stemming in the green. With this design, we did not have the ability to use sequential blasting equipment. By using dual air decks in the back row holes, this allowed the front row holes to fire slightly quicker than the back row of holes, creating better relief and less strain on the cables. As you can see here, we use conveyor belting as a secondary control, like we do in all construction and urban rock breaking situations. As we can see in this blast, we get more forward and upward movement, and also some shearing across the top of the cables. The design creates a nice clean shear on both sides of the block, reducing any pressure that would ordinarily be placed on the cables. Half-barrel drill holes can be seen on both sides of the concrete block. These half-barrel drill holes with an even shear between them indicates the perfect spacing distance between holes and perfect alignment of the drilling. Overall, this is an excellent and cost-effective result.